Hey, it's Mr. Loneski with the last video for Unit 3. It's Section 4. We're going to look at some proofs. Fun! Proofs with angle relationships. So, very first day of school, we did some algebra proofs, which seemingly went pretty well for the most part. And so we're going to kind of, as we go throughout the school year, kind of touch on a little bit more proofs and where we use proofs in geometry. So just as a quick little refresher here, don't forget about your algebra proof reasons. So some of the most commonly used ones were the 4 different POs. So that was your addition PO, property of equality, subtraction, multiplication, and division. That again was whenever you were solving an algebra problem, whatever you do to one side, you do to the other. And that was the property of equality. We had things like combining like terms, so that was if I had something like 4x plus 2x equals 10, and we would say, oh, 6x equals 10. That was combining like terms. Sometimes we called it CLT. And then substitution. So substitution was any time we established a variable was equal to something, and we could kind of substitute that value in. So what I'm going to do is kind of talk to you about some new reasons, some new things that we can use in proof, and some proofs that are a bit geared more towards geometry. And so one of them is called the definition of. Typically this comes up anytime we use a vocabulary type word and we're using any kind of part of its definition. So some common definitions that you're going to see are things like definition of supplementary angles. And so something that might look like is it could be something like the measure of angle 1 plus the measure of angle 2 equals 180. Basically, the definition of supplementary angles is anytime we say two angles add up to 180. Similarly, the definition of complementary angles, would be like measure of angle 1 plus measure of angle 2 equals 90. That's basically saying that two angles add up to 90. The definition of a right angle is when I establish that something is a right angle. So measure of angle 1 equals 90. Whoa, sorry. Let me write that over here. So that would be like if I gave you a figure and something was marked with a 90-degree angle, you could say, oh, I know that mark means that this angle is equal to 90 degrees. The definition of congruent segments. So segments are kind of like lines or pieces. Definition of congruent segments says that segment AB is congruent to segment BC if and only if, so there's that biconditional we talked about in Unit 2, if and only if the measure of AB is equal to the measure of BC. So remember, if and only ifs can work backwards. So if I tell you these two pieces are equal, these two pieces have to be congruent. Same thing with angles. I can say angle A is congruent to angle B if and only if the measure of angle A equals the measure of angle B. So one thing I want to point out to you is sort of the difference between these statements and these statements. These statements here are when we know the numbers. When we're putting numbers to problems. Equal signs allow us to say, oh, the measure of angle A equals 20 degrees, whereas I can't really say that. Congruent is when we don't know the measures. So just keep that in mind as we're doing proofs. If I have more than one right angle, I can say that any right angles are congruent to each other. That is called the right angle congruence theorem. So you can abbreviate some things here. So anytime I say congruence, it's cool to just draw the congruency symbol. If two lines form a linear pair, I can say they are supplementary. That is called the linear pair postulate. And then all vertical angles are congruent. So in other words, if two angles are congruent because they're vertical angles, that's called the vertical angle theorem. Some more commonly used things that we're using in this particular unit are all those angle relationships. So in a problem or in a proof, if we're told that lines are parallel, we are proving two angles are congruent based on an angle relationship. We can use these three things. So remember, congruent is alternate interior, alternate exterior, and corresponding. If we're proving two angles are supplementary based on an angle relationship, remember supplementary 180, that's our same side interior angle theorem. If we are ever trying to prove that the lines are parallel, that's when we're going to use the converses of all these things here. So same side interior angle converse, corresponding converse. So these are all things that we can use in proofs now as to like why can we do the things that we do in this class. So here's an example of a problem. If I give you that line M is parallel to N and A is parallel to B, so I know that these lines are parallel, I know these lines are parallel. That's told to me, that's given to me. I want to prove that angle 3 is congruent to angle 13. So right now, by just looking at 3 and 13, there's no direct angle relationship going on there. And so we're going to use a proof to help us. So remember, in a proof, typically our first reason is the given. So why can I say that these two lines are parallel? Well, because it was given to me. So now using the parallel lines, that means I'm going to be using some angle relationships. So right here, we are told the lines are parallel. So I should be seeing some of these things here. So why can I say that 3 is congruent to 5? Well, if we look at 3 and 5, hey, those are alternate interiors. So I'm going to use the alternate interior angle theorem. See how that works? The next one, 5 is congruent to 13. So if I look at that relationship, where's 5, where's 13? So 5 and 13, I'm kind of ignoring all of this stuff. 5 and 13, hey, those are corresponding angles. And when the lines are parallel, I can say corresponding angles postulate. So now one thing that you want to pay attention to is there's kind of, it's almost like law of syllogism, where this is P, this is Q, and this is R. If you notice, angle 5 gets used twice, and so we can link that together. Now we're not going to call it the law of syllogism anymore, because we're not talking about if-then statements. We're going to call this the transitive property, or if you wanted to think of it as a substitution. So if 3 is congruent to 5, 5 is congruent to 13, therefore 3 is congruent to 13. That's transitive property. Or if you want to view it as, hey, 3 is congruent to 5, and there's a 5 right here, I can substitute the 3 in for 5. So either one of those is appropriate. All right, looking at the next one, we're given M parallel to N. We're told that angle 1 is equal to 5x plus 11, angle 2 is equal to 6x plus 26, and we want to prove that x is equal to 13. So why can I say M is parallel to N? It's given to me. Why can I say that angle 1 plus angle 2 equals 180? Well, the relationship there is that those are same side interior angles, so same side interior angle theorem. So now here, I'm just re-establishing what 1 and 2 are. So that was given to me. So now I'm going to link this to this. So if I know 1 equals this and 2 equals this, I can substitute that information in for angle 1 and angle 2. Now, this just becomes an algebra problem. Notice the rest of the proof, we're just solving for x. So think back to our algebra proof stuff. So how do I get from here to here? I combined like terms. CLT, combine like terms. So now how do I go from here to here? I'm subtracting 37 from both sides. That's the subtraction PO. From here to here, what did I do? I divide both sides by 11, so that's our division PO. Okay, and we'll take a look at one last proof here. So one thing I want to point out here is that we are proving lines are parallel, so that means I should have a converse somewhere. Anytime you're proving lines are parallel, there should be a converse. So we're given that 5 is 30, we're given that 6 is 150, and so if you take a look here, that's my given. So the next thing says that 4 and 6 are supplementary. So if I look at this figure, why can I say 4 and 6 are supplementary? Because they're a linear pair. That's our linear pair postulate. So now why can I say that the measure of angle 4 plus the measure of angle 6 equals 180? That's the definition of supplementary. So anytime you see a vocab word like here, like in this, there's typically going to be a definition of somewhere. So okay, so these two things equal 180, so now what happened? Well, angle 6 got replaced with 150 right here. So that's a substitution. I substituted 150 in for angle 6. And now this kind of becomes like algebra. This is almost saying x plus 150 equals 180. Sorry, that angle sign doesn't need to be there. And so now from here, I just subtract 150 from both sides, so that's a subtraction PO. So now I know that angle 4 equals 30. And if I look back at the top, angle 5 also equals 30. So I can say that angle 4 equals angle 5, because I substituted the angle 5 in for 30, because they're the same thing. So now, when I switch from saying the measure of angle 4 equals the measure of angle 5, and I just switch to being congruent, that is when we say the definition of congruent angles. So remember, we can switch, that was our biconditional. We could have gone this way with it, congruent to equals or equal to congruent. And then the last step, we're saying, okay, the lines are parallel. So why are the lines parallel? Well, let's take a look at this relationship. 4 is congruent to 5. If we go up and look at our figure here, what's the relationship between 4 and 5? 4 and 5 are alternate exterior angles. So my reason is going to be the alternate exterior angle converse. Alright, so that is it for our proofs video. Thank you for watching. I know it, and now you know it.